With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us try to solve the given problem. So the given problem simply states a cannon is fixed to the floor of a carriage. So you can see a cannon here and it is fixed to the floor of this carriage, which is free to move without friction along a straight track. So this carriage can move along this track in a straight line. The combined mass of cannon and the carriage is capital M. So this cannon and carriage has mass capital M. The instant cannon fires a cannonball of mass m, small m, with a speed u, right? So this cannon fires a ball of small m mass with a speed u. Then the velocity of center of mass of cannon plus carriage plus ball. Now, how do you solve such type of problem? What is the main concept that we are going to use to solve this problem, right? So you can see here, initially or after this firing, there is no external force that is acting on the system, right? So all the forces that will be acting on this cannon ball that has been fired and on the cannon or this carriage will be simply the internal forces of this system of masses. And remember one main concept, which is that whenever external forces on any system of particle, here we have two system of particles. One is this small m and the other is this cannon and carriage, whose mass is simply capital M, right? So here we have three particles, but the collective mass of cannon and carriage is given. So whenever the F external on a system of particle is 0, then what actually happens is that its momentum of its center of mass remains constant. Now, what is the meaning of this? Which simply means, what is the formula for momentum? The formula for momentum is simply m into v com. So from here you can see that m into v com remains constant. Now here the mass is always constant, so this simply means that the velocity of center of mass is constant. So from this concept you can solve it very easily. Let us try to apply it. You can see that what was the initial velocity of center of mass, right? If you find out the initial velocity of center of mass, so you can see that the initial velocity of center of mass of this system of particle would be simply 0. And we have found out by this that the velocity of center of mass remains constant. So that simply means that even after this firing, this mass will move in this direction and the gun and cannon will simply recoil in this direction. So which simply means that the final velocity of center of mass would be 0. Now let us try to find this. So let us first apply conservation of momentum principle to find the recoil speed of this cannon and carriage, and let us see whether we get this result or not. You should remember this is very important result. Let us try to find out also. So let us see, let us take the recoil speed of this cannon and carriage is v, and this is fired with the speed u. So if you apply the momentum conservation principle, so what actually happens is that P initial of this system is equals to P final of this system. Now P initial is simply 0 since all the masses are initially 0, and when they are fired, then what actually happens is that this small m mass has u speed, so this will be mu, and you can see that this will have a recoil speed that is m into v. So from here if you find out v, that is the recoil speed, that will be simply equals to minus small m divided by capital M into u. Let this be equation number 1. Now how do you find out the velocity of center of mass? Let us apply the formula. Let us verify the result that we have found out. So velocity of center of mass is simply m into u plus capital M into v divided by whole mass, that is small m plus capital M. Now let us try to put the values here and let us see the result. So this you will see that small m u plus this capital M, in place of v we will write minus m divided by capital M into u whole divided by this mass m plus capital M. From here, you can see this will cancel out. So plus mu and minus mu, this will give you velocity of center of mass will be simply 0, which we had found out earlier. So this is the answer, that the velocity of center of mass would be simply 0. Now let us also try to understand this. What will happen? So you can see that initially the center of mass of this system will be somewhere, right? So when this ball will move in this direction, so the carriage and this cannon will move in this direction such that the center of mass will remains at that original position. So this is why we are getting the velocity of center of mass to be 0. I hope you understood the entire explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.